The energy system behind AI. Yesterday, we explored a simple idea. The next bottleneck for artificial intelligence may not be chips, it may be electricity. But electricity does not magically appear inside a data center. It moves through an entire system before it becomes AI. To understand the future of AI, we need to understand this system, a system that starts at power plants and ends with AI applications used by millions of people every day. The journey begins with creating power. Today, that electricity comes from a mix of nuclear power, natural gas, and renewable energy. Every AI model, every GPU cluster, and every data center depends on electricity generated somewhere in the real world. Each source has advantages and limitations. Natural gas can be deployed relatively quickly. Renewable energy is becoming cheaper. Nuclear power offers reliable 24-hour generation. This is why companies like Microsoft, Amazon, Google, and Meta are increasingly paying attention to energy production itself. Some are signing long-term power agreements. Others are investing directly in future nuclear capacity. The message is simple: no power, no AI. But generating electricity is only the first step. Electricity must travel from the power plant to the place where it will be consumed. This is where transmission lines, substations, utilities, and grid operators become critical. The challenge is not only producing enough electricity, the challenge is delivering it to the right place at the right time. Many of today's electrical networks were built decades ago. Meanwhile, AI infrastructure is growing at extraordinary speed. In some regions, new projects can wait years for grid connections. Utilities and grid operators are being forced to rethink how power is distributed across the system. The AI boom is becoming a grid challenge as much as a technology challenge. But even after electricity reaches a data center, the journey is not over. AI servers cannot simply plug into high-voltage transmission lines. Power must be transformed, stabilized, protected, and distributed. This is where transformers, switchgear, UPS systems, and electrical infrastructure enter the picture. Modern AI hardware is dramatically more power-hungry than traditional servers. Some next-generation AI racks consume many times more electricity than conventional computing equipment. At the same time, they generate enormous amounts of heat. That is why cooling systems have become one of the most important parts of the AI ecosystem. Without cooling, there is no stable compute. Without stable compute, there is no AI. Eventually, the electricity reaches its destination. This is the data center. The data center has become the factory of the AI era. It is where power, cooling, networking, storage, and computing come together in a single physical location. Only then does electricity become computation. Only then do GPUs train models, generate tokens, and power AI applications. This is the layer most people see. Companies like NVIDIA, Microsoft, Amazon, and Google operate here. But underneath them sits an entire energy system: power generation, power delivery, power preparation, power consumption. The AI revolution is not only a software story, it is not only a chip story. It is a complete energy story, and understanding that system may become one of the most important investment themes of the coming decade. In our next video, we'll look at the major players operating across these layers and explore where the biggest opportunities may be forming. Subscribe to NAVIXA for structured market insights.